Yeah. So is it visible?
Yes, sir.
Okay. So now this is the second type of DAC. Considering the disadvantage of the weighted register type DAC. So now, what is the R2R ladder type DAC? The R2R ladder type DAC is the most popular DAC. Here these R and twice R, this R and twice R and twice R is like a ladder type. Okay. So for this reason, this is called the R2R ladder type DAC. Okay. There is the two register, one is R, another is twice R. Hence the name. The op-amp here configured as the voltage follower as earlier as the weighted resistor. But the difference is that here the R is not only the single R, there is the R and 2R. Okay. The circuit diagram of the R2R ladder type DAC having the 4 digital inputs. Digital inputs means S3, S2, S1 and S0 are the digital, and VR is represented by the reference voltage. Some of the books write like this: A3, A2, A1, A0, where the A3 is the MSB and A0 is the LSB. The weighted binary number are the S3, S2, S1 and S0, where S3 is the MSB and S0 is the LSB. Okay. So we can write like this: S3, S2, S1 and S0. This is the digital input. Okay. So when the digital signals S3, S2, S1 and S0 is applied at the input terminal of the DAC, an equivalent analog signal is produced at the output terminal, just like this. Here this is the R, here this is the R, total Thevenin resistance we will get, and according to the applied voltage we will get the Thevenin voltage. So in the simple diagram like this, this is the Thevenin voltage, this is the Thevenin resistance, and this is the voltage follower circuit of the op-amp. Okay. So if we connect like this, the voltage source as the A3, A2, A1 and A0, or the VA, VB, VC, VD, different books shows different type. So, but in principle, these are the voltage sources, weighted voltage sources, where S3, S2, S1 and S0 are the digital data. I will come to the in later section by an example. So suppose this is a S3 is the MSB, S2 is the next MSB, next S1 is the next MSB and S0 is the LSB. So then if we put like this the equal digital voltage of this, then we will get the required output. So suppose this is a my R2R ladder network. How I will calculate the Thevenin resistance and the Thevenin voltage? Okay. First, suppose this is a 2R and 2R, these are the parallel. Okay. So if two resistance are parallel, then the equivalent resistance will be the half. So that means twice R into twice R by twice R plus twice R. So that means that is called the R. Okay. So if this is R, then we will put here as R by this. Then the series with R, this will be the R, this is the series with R, then twice R parallel, because the current is divided. Why it is parallel? The current is divided at the node as this. So for this reason, these R is parallel with these R and these R, the equivalent resistance R, these are 2 R are in series because same current will flow this 2 R, and this current is divided through the twice R and the R. So for this reason, these 2 R and these 2 R are in parallel. So we can write this R and R are the series, so twice R, and this twice R is parallel. So twice R is parallel. Then we will write again R. So then R, then again R, then again twice R here. So then again R and R in series, twice R in parallel. So then we will get again R. So these R and these R or these are the series, and these twice are in parallel. So this is the parallel. So R and R in series, twice R is parallel. So RTH is R. So from the previous circuit, here this RTH is R. Now we want to calculate. Is there any problem in this slide? Hope you will understand the Thevenin resistance, how it will be calculated. Okay. So now then come to the details in the Thevenin resistance, which I already told. Suppose these twice are in parallel. So then if we calculate this as a RA, so then this is R3 treated as R3. So R3 is series with these parallel combinations of twice R, R1 and R2. Then we will get the RA. So RA is equal to twice R. Then again twice R and twice R in parallel. So then we will get the R. So this is the R5 with the series. So series R and R is twice R. So then twice R again parallel with twice R and series with R. Here these twice R and twice R is parallel, series with R. Then we will get the twice R. Again this twice R and twice R parallel, we will get the R. So this is the Thevenin resistance. Now suppose this is your circuit, R and twice R. Now the first MSB, that is called S3. Your data is like this. Input data S3, S2, S1 and S0. Okay. Now this is the input voltage is like this, 1, 0, 0 and 0. Okay. So that means here this is the S3 VR as shown in the previous slide. This is the S2 VR. S2 is 0. So for this reason this is grounded. Here this is S1 VR. And this is the S0 VR. Okay. So this is the S3 VR and this is the S1 VR. Sorry, this is the S3 VR is connected first MSB when we will get 1, 0, 0, 0 as the input. So then what happens? Here this is the Thevenin resistance. Thevenin resistance is R. So R and R are the twice R. So this is the twice R. And this is the twice R connected with the VR. Please go through the first slide. Here. This is the twice R connected with the voltage S3 is equal to 1. Here. And all are the zeros. S2 0, S1 0, S0 0. No problem. So now the Thevenin resistance like this. Here this is the voltage is applied here. So the Thevenin resistance is this. So this Thevenin voltage is R. So R is series with R. So that means twice R. So the equivalent circuit will be like this. Twice R connected with parallel of twice R with the voltage source S3VR, where S3 is equal to 1. So now what will be the Thevenin voltage? So Thevenin voltage is nothing but twice R connected with VR divided by twice R plus twice R into VR. So what will be the voltage? VR by 2. So when S3 is equal to 1, first MSB is 1, then what will be the input voltage? Then that will be the Thevenin voltage. So Thevenin voltage is VR by 2. Again, if we go for the second input, that is the first MSB bit is 0. So S3 is 0, S2 is 1, S1 is 0, and S0 is 0. Then what happens? Come to the first circuit. Here. This is 0, that means grounded. This is S2 VR, that means 1 connected with the VR. This will be 0, this will be 0, and this is the twice R. So the R here, this will be the Thevenin resistance. So what will be the Thevenin resistance? That is R. So what is the equivalent circuit diagram for this? Equivalent circuit diagram is, here this is S3 VR. S3 VR is 0. Here this is S2 VR. That is VR only, because due to the S2 is 1. Due to the S2 is 1. This is 0. This is 1. This is 0. This is 0. Due to this is MSB, this is LSB. Okay. So input voltage is 0, 1, 0, 0. So that means 0, 1, 0, 0. Here the only input voltage is here. So the Thevenin resistance is like this. Okay. So Thevenin resistance is R. So R plus R. This is twice R. Parallel with this twice R. Here this is R twice R. Parallel with this twice R. For S2 VR, S2 is 1. So the VR is connected here. This is the twice R. Is 0 connected with ground due to the S3 is 0. So now the equivalent circuit is like this. What is the Thevenin voltage? Thevenin voltage is VR by 2. So the VR by 2 is applied 0, 0, 1, 0. That is S3. That is S2. That is S1. And that is S0. So here this is S3 VR is 0. S2 VR is 0. S1 VR is 1. And this is the S0 VR is 0. Due to S0 is 0, S1 is 1, S2 is 0, S3 is 0. Both are grounded. And only this twice is connected with the VR due to S1 is 1. So now what will be the Thevenin voltage and Thevenin resistance? Like this. So this is the twice R is R, R plus R is twice R. So twice R is parallel with this twice R connected with VR. See, twice R parallel with the twice R connected with the VR. And other portion, this is R, this is R, this is twice R, this is twice R, this is R, this is R, this is twice R, this is twice R. So now put the Thevenin voltage and the Thevenin resistance. So here this is replacing by this. We put the Thevenin resistance and the Thevenin voltage. So this is the Thevenin voltage. This is the Thevenin resistance connected with R series. This is R. This is twice R, this is twice R, this is R, this is twice R. So then we will write like this. What will be the value of this? What will be the value? This is the R and R, but this value should be written as from this circuit. Very simple. R by R plus R series. When we calculate the Thevenin voltage, what happens? This is the short circuited. So short circuited means this is the R and R is series and twice R is parallel. So R and R is twice R. So twice R by twice R plus twice R. Twice R by twice R plus twice R into VR by 2. Then we will get VR by 4. So VR by 4, Thevenin resistance R, including R and twice R from the circuit. So then you will get the final VTH. So final VTH is R divided by R plus R, twice R. So twice R divided by twice R plus twice R into VR by 4. Here we will get VR by 4. Here we will get VR by 4. So now this is put here. So this is R plus R twice R. So how we will get this VTH? Now VTH is equal to twice R by twice R plus twice R into the Thevenin voltage VR by 4. So what will be the voltage? VR by 8. VR by 8. Okay. So derive this expression. You should have the proper concept of the Thevenin resistance and the Thevenin voltage calculation. This is very easy. This is very easy. When you will calculate the Thevenin voltage, then eliminate the source, short circuit it, and then draw the Thevenin resistance with the reference voltage. Then you will get it. No problem. Put this value again for this network. For this network, put the Thevenin resistance R with the Thevenin voltage with the existing R and twice R, Then you will calculate this VTH finally. So similarly for 0001, so that means this will be connected here. This is the S0 VR. This is the S0 VR. This is the S1 VR is 0. S2 VR is 0. S3 VR is 0. Due to S3 0, S2 0, S1 0 and S0 is 1. So first this circuit, the Thevenin resistance will be the VR by 2. Thevenin voltage is VR by 2. Thevenin resistance is R connected with this. This is the R. This is the twice R. This is the twice R, and rest of the circuit is as it is. Then come to the second. Here this is the Thevenin resistance R, but the Thevenin voltage will be R plus R twice R. So twice R by twice R plus twice R into VR by 2. So then you will get the VR by 4. VR by 4. Put the value here. VR by 4 with the Thevenin resistance, with this R, and this twice R, like this. So this is the VR by 8 with the Thevenin resistance, with the existing R and twice R, then you will get the final voltage VTH is equal to twice R by twice R plus twice R into VR by 8. So that means VR by 16. So now if we come to the summing amplifier, what is happening? Here this is S0 VR. This is my R2R ladder network. Equivalent circuit is like this, by which you can calculate with the example. Okay. So now what will be the value? VTH is equal to when the S0 is 1, when the S1 is 1, when the S2 is 1, when the S3 is 1. So what will be the value? Now that is equal to when S3 is 1. First, this is VR by 16 when S0 is 1, as derived before. Now put S1 is 1. What is the value? Now VR by 8. When the S2 is 1, we will get VR by 4. When S3 is 1, now VR by 2. Now if we take the common of VR by 16, that means VR by 2 to the power of 4, VR by 2 to the power of 4, then you will get like this S0 into 2 to the power of 0. Here, this is the for S1, this is the for S0, S1, S2, S3. So this is for S0, this is for S1, this is for S2, this is the weightage, okay, binary value, and this is the S3. So take the common VR by 16, then S0 2 to the power of 0, S1 2 to the power of 1, S2 2 to the power of 2, S3 2 to the power of 3, VR by 2 to the power of 4. Okay, VR by 2 to the power of 4, S0 2 to the power of 0, take the common of VR by 16, S1 2 to the power of 1, S2 2 to the power of 2, and S3 2 to the power of 3. So in general, if this is a 4-bit DAC, so in general, if there is an n-bit DAC, then what happens? If it is n-bit DAC, very simple. That is VR by 2 to the power of n, S0 2 to the power of 0, S1 2 to the power of 1, S2 2 to the power of 2, to Sn 2 to the power of n. Very simple. So now this, if this is a total number of n bit, then we will write like this. So the output voltage, this is an inverting amplifier. So we can write V0 is equal to minus RF by RTH into VTH, where VTH is the summation of, this is the n bit summation, that is VR by 2 to the power of n, 0 to n minus 1, Sk 2 to the power of k, as I write like this. Here we will write for n bit VR by 2 to the power n into summation of n is equal to 0 to, or k is equal to karo better, k is equal to 0 to n minus 1 s n minus 1 or sk করে দাও সবচেয়ে better, sk, sorry, erase it. That is the, suppose this is Sk 2 to the power of k. This is the in general value of the VTH. So from this we will write V0 is equal to minus RF by RTH. RTH is equal to R. So RF by RTH into VTH. This is the VTH for N. So then we will write as similar is this. Okay. So any bit 6 to 20 bit DAC based on the R2R network is commercially available in the single chip format. Okay, and also the bipolar CMOS or the BiCMOS technology used for this DAC. Okay, these are the very much important multiple choice questions for GATE. This 6 to 20 bit DAC based on the R2R ladder network is commercially available in the chip format. Now come to the two examples. And 4-bit R2R ladder type DAC. 4-bit, that means N is equal to 4. Have the resistor values of R is equal to 10 kilo ohm and VR is equal to 10 volt. Find the resolution and what is the value of I0 output current for a digital input 1101. From the previous lectures where the resolution was discussed, the resolution of 1 LSB is equal to 1 by 2 to the power of n VR by R. So put the value of n 1 by 2 to the power 4 into VR is 10 volt and R is the 10 kilo ohm. So 10 into 10 to the power 3. So then you will get this. So now for the input, what is the value, decimal value of this? 13. So this is the resolution. That means 1 bit size. So 1 bit size into the total number of bits. So that means 62.5 microampere bit size. And this is the total number of decimal value. Total number of steps are available. So then we multiply it, we will get the I0. For the second type of problem, suppose an 8-bit R2R ladder having the feedback resistance RF of the op-amp is variable. The resistance R is equal to 10 kilo ohm, uses the VR is equal to 10 volt. Determine the values of the RF that should be connected to achieve the following output conditions in reverse way. Here the 1 LSB value is given. So first is 1 LSB is given, R is given. So R is 10 kilo ohm, VR is 10 volt, N is the 8 bit. Here this is the, 8 bit, this is the 4 bit. This is the 4 bit, sorry. This is the 4 bit, 1 minute, yeah, this is the 4 bit. This is the 4 bit. So N is equal to 4. The value of 1 LSB is 0.5 volt. So what will be the value? Now this is the 0.5 volt is 1 LSB. So 1 by what is the value of 1 LSB? Now 1 by 2 to the power of n VR by R. So put here 1 by 2 to the power of n VR by R. R is the 10 kilo ohm. VR is 10. Okay. Into RF. So RF here. This is the value. So we will get the value of RF here. For the binary output 1000. So 1000 means MSB bit is 1. All are the zeros. Okay. So what will be the value? So RF into 10 into 2 to the power of minus 1. Because here this is the 2 to the power of n. Okay. So this is the 1 bit, first bit. So for this is in 2 to the power of minus 1. If it is B2, B3, B4 are 0 actually. Okay. So this is the B1 is 1, B4 is 0, B3 is 0, B2 is 0. Here this is the MSB actually. The written over here B1, B2, B3 and B4. Or very simply, suppose this is a S3, then S3, S2, S1 and S0. So first MSB bit is 1. So for this reason, this is here. If this is the second MSB, then this will be 2. Okay. So 2 to the power of 0. What will be the value? 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, all are zeros. Okay. And but this is, sorry, this is the, actually this is the value of S3. That means this is the B1, this is the B2, this is the B3, this is the B4. If there is all of the ones, then you should write that 1 by 2 to the power of, this is 2 to the power of minus 1. That means 1 by 2 to the power of 1. Then 1 by 2 to the power of 2. If there is any 1. If this is 3, then 1 by 2 to the power of 3. If this is 1, then 1 by 2 to the power of 4. All of the summation. Then you will get the total value. Here the only 1 is connected. That means the first MSB bit is connected. Okay. So the formula is RF into 10 divided by R. That means VR. Okay. RF into VR by 2 to the power of n. 2 to the power of n means here this is only 1. Okay. So 2 to the power of n is 1. So 2 to the power of n is equal to, what is the value? Now value is 6 volt. The output voltage. Sorry, the output voltage. So put the formula as like this. This is the RF. This is the RTH, that means R. This is the VTH. Put the value here. This is very simple. Okay. N is equal to 4. N is equal to 4. Here this is SK means 3. Okay. So 3 means, if I put the value, this is complicated written over here. If I put the value in general case, what will be the value? Suppose B0 is equal to minus RF by R into VTH. So VTH, what is the value of VTH? VTH is nothing but summation of 1 by 2 to the power of n into, what is the value? Summation of k is equal to 0 to n minus 1 sk 2 to the power of k. Now put the value here. What is the value? Please don't care of this. What is the value? S3 is 1, S2 is 0, S1 is 0, S0 is 0. So only we will get here k is equal to 3. Okay. So k is equal to 3, n minus 1 to. K is equal to 3, that means S3 2 to the power of 3. So what will be the value? 1 by 2 to the power of 4, 2 to the power of 4 into k 2 to the power of 3. Then what will be the value? Half. That means 2 to the power of minus 1. Clear? Why it is 2 to the power of minus 1? This is the V0. So this is the voltage. So this is the RF value of RF. Now the second, this is the full scale value, 12 volt, resolution. Just full scale value means resolution. So RF into VR by 2 to the power of n, 1 bit LSB. Put here is equal to 12, then we will get the RF. Now all are the 1. Actual the maximum output, maximum up to when? When all are the 1. That means S31, S21, S11, S01. So put the value here. 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, 2 to the power of 0. What will be the value? 15. Okay. So 15 by 16. 15 by 16. So what will be the value? Please don't care this. Put this. Put this. 15 by 16. Here. Here this is the 15 by 16. Put the value, then you will get the bolt RF, actual RF. Okay. So these are the two problems. Here we discuss different types of problems in a single problem. If there is any problem, please discuss again. I will discuss again. If there is any problem, I will give some homework through your WhatsApp and you can solve it. So if there is any problem, please ask me. Is there any problem? Hello? Sukarna is there? Sukarna? Yeah. Okay. Why? I actually allow the participants unmute themselves. Please try.
Yes, sir. Now it's working.
So is there any problem? Please practice.
Yes, sir. Now I can.
Otherwise, you cannot able to solve this problem in the exam. Please practice it. It is the very much conceptual on the Thevenin voltage and the Thevenin resistance. But otherwise, it is very easy. Okay. You should calculate the Thevenin voltage and the Thevenin resistance, and it is very easy. When you will calculate the Thevenin voltage, you should eliminate the voltage source connected with the short circuit and then calculate the Thevenin resistance with the voltage. So then there will be no problem. Please go through my lecture. I hope you will be very much you will very much learn about the R2R ladder network. If there is any problem, please ask me.
Yes, sir. There is actually a problem. Sir, can you please explain the last part once again, sir?
Yes. No problem.
Yes.
Yeah. Is it visible?
Yes, sir.
Yeah. So last part means last problem.
Yes, sir. You have told that we have to ignore something and then you solved it.
Yes.
So that portion wasn't clear to me.
Okay. Suppose this is a maximum output. When I will get the maximum voltage at the output? When the all bits are 1. So S3, S2, S1 and S0 all are should be 1. Now calculate the VTH first. What will be the VTH? What will be the VTH? 1 by 2 to the power n into S3 2 to the power of 3 plus S2 2 to the power of 2 plus S1 2 to the power of 1 plus S0 2 to the power of 0 as Sk 2 to the power of k. Now put the value 1 by 2 to the power of 4 into 2 to the power of 3 plus 2 to the power of 2 plus 2 to the power of 1 plus 2 to the power of 0. Now multiply with the 2 to the power of 4. Then you will get 2 to the power of minus 1, 2 to the power of minus 2, 2 to the power of minus 3, 2 to the power of minus 4. So the V0 is equal to Rf by R into VR into this, into VR, into VR. This is the VTH. So put the value of VR here, 10 volt into Rf by R, then VTH. This is the VTH is equal to 10 volt. Then you will calculate the Rf. Clear?
Yes, sir. Now understood. Yes, sir.
Okay. You should consider only this. And how this will make from this. And how this will make from this. Okay. And step by step like this. Okay.
Yes, sir. Understood.
You should calculate this Thevenin voltage, this Thevenin voltage, this Thevenin voltage, and when the LSB bit is 0, this LSB bit is 1, this Thevenin voltage. From where you will write this, and then you will get the common in general form for any n bit number of DAC. Okay. For gate, this will be very important equation. Any type of problem you will get, you should apply this formula. RF calculation, resolution calculation. Resolution calculation is nothing but a 1 by 2 to the power of n into VR. So then you will get it. If there is any Thevenin voltage, you should calculate like this. This is the Thevenin voltage. What is the Thevenin resistance? Simply R. What is the feedback resistance? This is the RF. So any type of problem during the gate exam, you should apply this formula. Okay. Please go through this. So in the very next class, it probably on Saturday. Okay, I will take the class, I will send the link, and I will teach you the ADC, analog to digital converter, successive approximation method, DAC. This is very interesting and algorithmic type. Okay, I will discuss it on the next class on Saturday.
Sir, hello sir, इसी 2B की Saturday class है क्या?
Sorry?
इसी 2B की Saturday class होगा ना?
Yes. Two classes today.
कौन से sir?
Most probably it will be on 10 a.m.
Okay sir, because we have a class from 12 and there is a class, there is a slot exam from 3.
So please inform the other teachers. I will take the class on Saturday 10 a.m.
Okay.
morning.
Okay.
1 hour class. No problem.
Okay sir. Thank you sir.
So good night.
Good night sir. Sir,
Good night, sir.
attendance link is open by madam.
Sorry.
Attendance link.
Attendance link sent by mobile email.
Okay.
You should collect
okay
it.
sir. Okay.
Okay. I will send
Thank you.
the PPT and the video. No problem.
Thank you sir.
Thank you, sir.
Okay.
Thank you.
Thank you.